going to be solving Igcse Organic Chemistry past papers, and the topic for which we're going to be solving the questions is going to be formulae, functional groups, and terminology. So the questions are going to be related to these things, right? We're not going to be dealing with the reactions in this video. We're going to do it in the next. There are questions for the reactions in chemical formulas and that thing. But over here, we're just going to make it like the simple beginning of the organic chemistry. Questions are applicable for both the core and the extended candidates for paper. This is paper 1, that is why it's for both, but as we're gonna progress, we're gonna see paper 2 as well, which is only gonna be for the extended candidates. So first let's solve paper 2 because it's gonna be a little hard. Then we can do the paper 1 thing. Which molecules are structural isomers? Structural isomers means that firstly the chemical formula should be the same. So first let's drive the chemical formula of each of the compounds. If I look over here, the number of carbon atoms is 1, 2, 3, 4 and 5, right? So it's going to be C5. H is going to be, number of hydrogen atoms are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C5H12, the formula for this compound. Next formula is going to be for carbon we're going to use, the colors are very important. Like if you're going to use a single color for one, it's going to help you. So 1, 2, 3, 4, 5. It's going to be C5 and H is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C5H10. Now look, the chemical formula of this and this is not the same. So these cannot be structural isomers. For structural isomers, same chemical formula but different. Same molecular formula. You can also call this molecular formula but different structures, right? So now let's see for number 3. We have 1, 2, 3, 4, 5 carbon atoms. So it's going to be C5 and H is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C5H12. Now you can see for yourself that this and this have the same molecular formula, but still we're going to look for the structures as well. First we're done with all the molecular formulas. 1, 2, 3, 4, 5, 6. So it's going to be C6H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C5H12. Done? 1, 2, 3, 4, 5, 6. Okay, now we're with something interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my god. Now you have to look for something different, right? This one is gonna be a complete cross, right? Because it has a different molecular formula. But for this, and this, you would have to check which are structural isomers, right? Which have different structures. If you look over here, 1, 2, 3, 4, 5, 1, 2, 3, 3 plus 3 times 9, 12. Done. Okay, this is a straight chain, and on the second carbon you have a methyl group attached, right? So this is going to be 2 methyl, because on the second carbon you have a methyl group. This is first carbon, second carbon, third carbon, and fourth carbon, right? On the second carbon you have a methyl group, so 2 methyl, and it's a straight chain 4 carbon, so 2 methyl butane. Good. If I look for this, the longest carbon chain is, I guess, this one, right? So on this 1, 2, 3 carbons, so it's on the second carbon there are 2 methyl groups, so 1 methyl group above, 1 methyl group below. So it's 2,2-dimethyl propane. Okay, 2,2-dimethyl propane. Propane, why? Because the longest chain has 3 carbons, so it's going to be a propane chain. And 2,2-dimethyl, because this and this are going to be 2 methyl groups on the second carbon. Now this one, it has 1, 2, 3, 4, 5 carbons, so it's an alkene because it has a carbon-carbon double bond. So over here we're gonna write it's 1, 2, 3, 4, 5, so it's pentene, 6 carbons. Oh, it's C6. I didn't watch for the 6 carbons, but still you're gonna name them pentene. And 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. On the 4th carbon you have a methyl group, so 4 methyl pentene. Got it? 4 methyl pentene. Now out of these, which two are structural isomers? 2-methyl butane, 2-methyl butane, and 2,2-dimethyl propane, because they have the same molecular formula and different structures. How do they have different structures? You can see the names are different, hence the structures are also different. Why not the 4th one? Because 4th one is C6, the 6 carbon atoms. We're only looking for 5 carbon atoms. So 1 and 3 are gonna be your structural isomers. The structural formula of the compound Q is given. What is compound Q? This is the structural formula, and I'd like if you guys draw it, because drawing is gonna help you understand. So carbon, hydrogen, 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 CH3, this is CH3, right? Then there is CH2, so C, H and H, and then there is again a CH2, so C, H and H. Then there is COO. This COO is very important. People think it's C, then O, and then O. No dear, it cannot be like this. COO means that you have C double bond O and O. Why? Because otherwise the valency is not going to be filled for this carbon, because this carbon is only attached to one other carbon. So if it makes a single bond with this O, the valency is not going to be fulfilled. Why? Because carbon makes 4 bonds, right? Because it has 4 valence electrons. Over here it's only making 1. That's not acceptable. Okay, got it? So it's going to be C double bond O, then again there's going to be a C, H and H, and there's again going to be a C, H and H, CH2, CH2, and then there's going to be a C, H and H. Done? Now you can see something over here. This is an ester linkage, right? Before this double bond, this entire part is your acid part. Okay, this came from the acid. This is also included in the acid part, and this entire part comes from your alcohol. Got it? So how much carbon acid is this? 1 carbon, 2 carbon, 3 carbon, 4 carbon. So basically you joined butanoic acid. How do we know the acid part? The part that is before the C double bond O, and part that's after the O is going to be our alcohol part. Which alcohol? 1, 2, 3 carbon alcohol, butanoic acid and propanol. So this is going to form propyl butanoate. So what are we going to form? Propyl butanoate. Got it? Because the alcohol comes first and the acid comes after it. So propyl butanoate is gonna be your answer. You have to learn the structures. Okay, the structures of 2 molecules X and Y are shown. Which row describes X and Y? Structural isomers belongs to the same homologous series. Now these are a little tricky questions. First, to understand that are these structural isomers, you have to count the number of carbon atoms in hydrogen and write the molecular formula. 1 carbon, 2 carbon, 3 carbon, 4, 5, 6, 7. So it's C7 and H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. C7H14. Okay. Now for this one, we also have to again count the number of atoms. 1, 2, 3, 4, 5, 6. So it's C6H is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6H12. Got it? Now you can see that the molecular formula of both the compounds C7H14 and C6H12 is different, right? They're not the same. So to have structural isomers, you should have the same molecular formula, so they're not structural isomers. Next, belong to the same homologous series. Now what are homologous series? Homologous series is a group of series like your alkanes are homologous series, all have the same general formula. The chemical properties are similar, the physical properties show trends, the functional groups are the same, that thing. And then you're gonna have your alkenes, and then your alkenes are also homologous series. So over here, the alkene part is this and this. These are your alkenes, right? You can see it for yourself that both have alkenes. So that means they belong to the same homologous series. Despite having different molecular formula, the molecule is different, yeah, but the functional group is the same. So they're the same homologous series. So yes, which makes this the correct answer. Understood? Which statement defines structural isomers? Structural isomers mean that same molecular formula, again, matlab the C7H14, and then it should also be C7H14. Same molecular formula but different structures. They are compounds with the same displayed formula but a different molecular formula. No, we're not talking about the same displayed formula, we're talking about the same molecular, different structural. Just remember this for structural isomers. I'm writing this mantra: same molecular, different structural. Got it? Same molecular, different structural. They're compounds with the same molecular and displayed formula. No, we're not talking about the displayed, only same molecular, different structural. They're compounds with the same molecular formula but different structural formula. Exactly, that's what we're looking for. Which statement about structural isomers is correct? They have the same structure but different reactivity. No. They have the same general formula. Same molecular formula. They have the but different number of carbon. No. If you have different number of carbons, how come you have the same molecular formula? Molecular formula involves the number of carbon. They have the same structure. No, they're structural isomers, so the structure should be different, yeah? They have the same structure. How can they have same structure? Structural isomers, they should be different, right? They have different structures, yeah, but the same number of each type of atom, yeah. Same number of each type of atom means that the structure is going to be different, but the molecular formula, which is the number of atoms, right? C7H10, for instance, and then there is again C7H10. You might think, what kind of formula is this? Yeah, all formulas are possible, right? Over here, all formulas are possible. Same formula, same number of atoms, but the structure for this C7H10 and this C7H10 is going to be a different, right? Like this might be a ring or this might be a straight chain. So that are the differences in the structure. Next, which formula is the same in methanol, ethanol and propanol? The general formula. Empirical formula, general. Look, they all are same homologous series. Can you see this? All are alcohol homologous series. When you're dealing with alcohols, all are alcohols, right? All alcohols. That means they're alcohols, so they're gonna have same general formula, because a homologous series, all the members of a homologous series, like all the alkanes, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, they're all gonna have the same general formula despite different molecular formula. Empirical formula might change, structure might change. Like if you are dealing with the structural isomers within the same homologous series, like the alkenes, like but-1ene and but-2ene, they're two structural isomers, right? Because the structures are different. In the but-1ene, the double bond is on the first carbon. But-2ene, the double bond is on the second carbon, right? Despite having different structures, they have the same general formula because they belong to the same homologous series. They're the same molecular formula as well. But still, molecular formula for a homologous series might change because methanol, ethanol, and propanol, obviously methanol has the molecular formula of CH3OH, right? CH3OH. Ethanol is going to be C2H5OH. Propanol is going to be C3H7OH. All different molecular formulas, same general formula. So with that, we're done with the extended part of it. Now let's move to the core part. Which compound is a member of the alkene? Alkene homologous series, right? You just need to know the general formula, CnH2n. That means the hydrogen atoms should be double of the carbon atoms. If you have 2 carbon atoms, the hydrogen should be double of it. It should be 2n. 2 times 4. So C2H6, the hydrogens are not double. Double of 2 is 4. So this is a cross. C4H10, double of 4 is 8. So hydrogen should be 8. This is again a cross. C6H12, the double of 6 is 12. This is correct. Because for alkenes, you need the double hydrogens. Which formula represents caffeine? Okay. Caffeine is a stimulant found in coffee. You have to count the number of atoms again. For the carbons, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbons, 7 carbon, 8 carbons. So C8, now H. H is gonna be 3 plus 3. 3, 4, 5, 6, 7, 8, 9, 10. C3H10, N is gonna be 1, 2, 3, 4. N4, and O is gonna be 1O and 2O. O2. So C8H10, C8H10N3O2. That's the answer. You just have to count the number of atoms for the molecular formula. And this type of formula is called the molecular formula. This, in which you just write the number of atoms. And this type of formula is called the displayed formula, in which you display all the bonds. Like not all the bonds, there's still some bonds undisplayed, but like if you display them as well, it's going to be the displayed formula then. In which lists are the compounds in the same homologous series? Okay. CH4, methane, alkane homologous series, right? Alkane homologous series. C2H4, ethene, right? Because the hydrogen is double of carbon. What homologous series is this? Alkene homologous series. C3H8. Again, the general formula for this is coming out to be CnH2n plus 2, right? So this is again propane, which is your alkane homologous series. So all the things that don't belong to the same homologous series, it's alkane. Number 1, this CH4 is alkane, C3H8 is alkane, but C2H4 is alkene. So this is a cross. CH3OH ethanol, C2H5OH sorry. CH3OH is methanol, C2H5OH is ethanol, and C3H7OH is propanol. So methanol, ethanol, propanol, all belonging to your alcohol homologous series. So 2 is correct. CH3COOH ester linkage or alcohol carboxylic acid linkage. You have to check it, right? If it's at the end, like over here, then that's going to be carboxylic acid linkage. So let's check it. CH H H C double bond O O and H. So now you can see it for yourself. This is your ethanoic acid. Okay, we have an acid here. Then this is your alcohol. You can see 1, 2 carbons. This is your ethanol. And this is your 1, 2, 3 carbons propanol. So over here, only 2 has all the same with the same homologous series. So 2 only. Because 3 has acid, alcohol, alcohol. The 1 has alkene, alkane, alkane. So not correct. The next question states that which structure is correctly named. First we have ethanoic acid. You should remember this thing, that eth always means 2. So ethanoic acid should have basically 2 carbon atoms. Over here we can see it's 1 carbon, 2 carbon, 3 carbon. So 1, 2, 3 carbon atoms. So this is not ethanoic acid, this is your propanoic acid. Then we have ethene. Ene means, the ene part in ethene means that there should be a carbon-carbon double bond in it, because ene indicates that this is an alkene, which this, you can see it for yourself, it's not, it's an alkane, right? And a 2 carbon alkane is going to be called ethane, not ethene. Then next we have ethanol. Ethanol means an alcohol that has 2 carbons, because eth is going to mean 2, and we can see over here we have 1 carbon, then we have 2 carbons, and then we have an OH group. The OH group is going to tell that this one is an alcohol, and carbon 1 and carbon 2 is going to tell that this one is ethanol. So this is correct. Then we have propane. Propane, the ane part tells it's an alkane. An alkane means that there are carbon-carbon single bond. Over here we can see a carbon-carbon double bond. So this one is not an alkane, this is an alkene. So this is not propane. This one right here is propene. So this one is also incorrect. Hence option C is the correct answer. What is the formula of this compound? Firstly, we have to realize that, let's draw a displayed formula for this. So the this big one is a carbon atom. So we have 1 carbon, we have 2 carbon, we have 3 carbons. So carbon, 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 3 carbons, right? Then this one is an O. This one is going to be an O, attached to an O and then attached to an H. So let's do H with a different color. Let's use this one for the H. So attached to an H, and then there are 1, 2, 3, 4, 5, 6, 7 H's covering it all. 1, 2, 3, 4, 5, 6 and 7 H's. So that makes it 1 carbon, 2 carbon, 3 carbon. 3 carbon is gonna make it prop, and then you can see that there is an OH group over here, right? So that means it's an alcohol, so it's propanol, right? So it's gonna be propanol, which is gonna be C3. Let's count the total hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, C3H8O. C3H8O. Done and dusted. Next question, how many different homologous series are shown in these equations? Okay, how many different homologous series? Firstly, C4H10. You should know that the general formula for an alkane is CnH2n plus 2. So that means this one is going to be an alkane. This one is C2H4. C2H4 general formula for alkene. We can see it because the hydrogens are exactly double of the carbons. So it's CnH2n. Next we have C2H6. Again, this one is going to be an alkane. Why? Because it obeys the general formula CnH2n plus 2. Again, this one is an alkene. H2O. How many different homologous series? Homologous series are of only organic compounds. Remember, water is inorganic. You should remember this thing, that water is inorganic. Inorganic means that it is not an organic compound. Why? Because water does not has any carbon in it, so we are not going to consider water over here. Then C2H5OH, you can see this is, I don't think it needs any explanation. It is an alcohol, the most famous one, which is your ethanol, right? C2H5OH is your ethanol. So till this time we have discovered this alkane series, then we've discovered this alkene series, then we've discovered this alcohol series, and then we're dealing with homologous series. Again, alcohol, oxygen is not a homologous series, carbon dioxide is not homologous series, right? Homologous series means that it should have a general formula and the members of the series should obey the general formula. We have not studied any general formula for carbon dioxide, right? Though it's organic because it has carbon, that makes sense, but it's not a homologous series. The homologous series in our syllabus are your alkanes, then it is your alkenes, then it is your alcohols, 3, number 4, it's your carboxylic acids, and then you have your esters as well. Esters are also homologous series. So these are the homologous series that have a fixed general formula and all the members are going to obey. But esters are also not very important homologous series. These 4, they're like the important ones. So over here, I think we only came across 3 homologous series. One was alkanes. The first one was your alkanes, then we came across alkenes, and then we came across alcohols. Next, the structures of 3 organic molecules are shown. The first one is your methanol, right? Because we have 1 carbon atom and then we have an OH. So this one is methanol. Next, we have 2 carbon atoms and a C double bond O OH. This is going to be your ethanoic acid, right? Because 2 carbon atoms and then C double bond O, it's ethanoic acid. And then you have 1, 2, 3 carbon atoms and an OH. So that's going to be your propanol. So which description of the 3 molecules is correct? They all have the same general formula, CnH2n plus OH. This one is for alcohol, so it's correct for methanol and propanol, but not for ethanoic acid. They all belong to the same homologous series. No, they don't. No, they don't all belong. No, they don't all have, because one is your ethanoic acid. Now, you know why this question is given? So people confuse the OH and OH and OH. That's incorrect. It's C double bond OH. And then it's OH and OH. So that's why. So it's going to be option number A. Part of the structure of a molecule of vitamin A is shown. So this is vitamin A. Which statement about the part of the structure is correct? It is saturated. No, it's unsaturated. Saturation means, so I'm going to write over here that your saturation means only we're talking about carbon-carbon. All carbon-carbon bonds, all carbon-carbon bonds are single. Oh, let me remove the double bond. All carbon-carbon bonds are single. This is what saturation means. You can say it is not saturated because you can see the carbon-carbon double bonds, right? This is saturated because the carbon-carbon bond is single. But this one right here is unsaturated because the carbon-carbon bond is double. It is saturated. No, there are 2 alkene groups. Yeah, that's correct, because 1 alkene group you can see over here and 1 alkene group here. So this one's correct. The structure shows a carboxylic acid. The structure shows a carboxylic acid. No, carboxylic acid has a functional group that's pretty distinct, which says C double bond O OH. That's a carboxylic acid functional group, right? But over here what we can see is that we have an alcohol functional group. So this one right here is an alcohol functional group. So this one is also gross. So only 2 is correct. Next question states that which one identifies the homologous series to which the molecular structure belongs. Okay, this one is all carbon-carbon single bonds. And how many carbon atoms we have? 1, 2, 3, 4, 5, 6. So that's 6 means hexane. Okay, 6 means it's going to be hexane. So that's going to be an alkane. That's correct, right? Then This one right here is methane, ethane, because there are 2 carbon atoms. So that's a alkane, not an alkene. This is incorrect. Then we have 1, 2, 3 carbon acid, which is your propanoic acid. So that's an acid, not an alcohol. Then we have 1, 2, 3, 4 carbons. 4 carbon means it's going to be a butanol because we have an OH group over here. So that is your butanol, not a carboxylic acid. Again, cross. So this should be an alcohol because you have alcohol functional group, that's OH. If there was a carboxylic, it would have been this, right? Like this. So this is basically swapped. That's incorrect. Next, we have which type of compound is also a name of a homologous series? Carbonate. No, there is no carbonate homologous series. Yeah, we use carbonates, but carbonates are used like methanoate, propanoate, or we use the 8 part is used like alkane, alkanoate, or your alkyl alkanoate. In chemistry, we use 8 part, but carbonate like sodium carbonate or potassium carbonate, that's not a homologous series. Carbonate just means CO3 2 negative. This is what a carbonate means. So if you have sodium carbonate, it is Na2CO3 2 negative. 2 negative you can erase because we've added it, balanced it with the positive, the sodium. If you have potassium carbonate, it's going to be K2CO3. So carbonate just means there's going to be a CO3 2 negative. That's a carbonate. It's not a homologous series. There's not going to be any trend if you increase the number of carbon atoms. That stuff, it's incorrect. Carboxylic acid, yeah, we studied it. Carboxylic acid has the general formula of CnH2n plus 1 COOH. That's very important. You should remember it's going to be this halide. Halides, the group 7 salts, you call them halides like chlorides, bromides, iodides, but that's for the salts. And hydroxide, sodium hydroxide, potassium hydroxide, it's not a homologous series, it's just like name of the salts, right? And with that, we're done with the formulae, functional group, and terminology thing. Thank you.